Good. Okay, my name's Steve Pagden. I'm a retired engineer, and was asked by the community contact tracers, having been a volunteer for a while, to have a look at air quality and ventilation within community settings. And we work with an outfit called Heeley Trust, and a couple of projects have been run there. But first, I want to dive in and just go back a bit and look at air quality in general, and then build that up to the venues we went to. So just running through the composition of air, we all know it's mainly nitrogen, oxygen, a little bit of water that's variable, and then a tiny bit of argon, and then everything else you can barely see in that tiny little sliver there. So all the things that contribute to poor air quality still hardly make up anything we can even measure, literally parts per billion or parts per million. And the things that are looked at in external air quality that we're aware of would be CO2, we're aware of that for global warming. NO2 is studied in cities, ozone, and these things called PM10s, PM2.5s, which are actually not gases, but solid matter that are in the air. And there's loads of other things as well. Water, of course, that's our climate, and the hotter the world gets, the more water will impact on societies around the world, be it famine or drought or flooding. I'll just move on a slide, just 1 second. Look out what button to press. Right, so a quick one on CO2. Here's how CO2's gone up over the last 50 odd years, 60 years. And it's gone from 300 ppm to well over 400 ppm. The sawtooth here is completely down to the effect of summer and winter. CO2 goes down in the summer as due to growth, and up in the winter on that. And despite it being only 0.04% in the atmosphere, 400 ppm, it supports all plant life through photosynthesis. And the reason it's going up, of course, is our fault through the combustion of carbon-bearing fuels. And basically, we're all responsible. I would suggest by things we buy, because it's CO2 is emitted in everything we purchase that has to be made, travel, and then heating our homes, and of course, cooking. And then coming back to atmospheric pollutants, well, they impact on health. And here's a study from the European Environment Agency. They publish data from the EU, all the countries there. And I've highlighted just Ireland, which is a relatively small, widespread population, low population density, relatively low population.
Young ladies are my age in bathing suits.
Washed by the sea, okay? And their numbers, broad numbers on pollution, are much lower than the rest of the EU 27. And the effect is the deaths down to various pollutants are a lot lower, okay? However, there is some relatively better news in that this is data at the bottom from the UK, that things like the PMs, the particulate matter that's in the air from cars, combustion, or whatever, is gradually coming down because it's being monitored, and it's also being legislated for what levels have to be at. So there we are, it's coming down over time. And this second graph shows in the UK where emissions have come from, and it's by date. So you can see that as time has gone on, emissions in total for PM 2.5s have come down. However, in domestic situations, they're going up a bit, and that's being put to wood-burning stoves. So there's a dichotomy. Wood-burning stoves reduce the carbon CO2 impact, but are likely to increase health impacts. And in summary, basically, because outside air quality is basically legislated around the world, there's good news in that levels are gradually coming down. And the important point is the accountability exists for the secondary state of the environment in DEFRA. Now coming on to internal environments, and here we are, a person standing in a room surrounded by other people and may be subject to internal and external pollutants. And of course, our buildings are the solid walls and windows will help prevent external pollutants coming in, but they will also prevent internally generated pollutants coming out. So internal pollutants include what we sort of emit as being people, but also these things, VOCs, which are volatile organic compounds. Essentially, every aerosol you spray will emit VOCs, and they eventually disappear into the atmosphere. Where do they go? What happens to them? Damp and mold are really important certainly in certain lower quality housing. Big issue there, and that leads to airborne spores, and that can seriously impact people's health. And of course, we all breathe, so therefore we breathe out CO2, and CO2s in rooms can build up, and that can lead to reduced concentration, etc. And essentially, this little picture down here is not what I intend to have after this talk, but basically the atmosphere, the air in a building is a cocktail of stuff. There's all sorts going on, reactions going on, and that sort of needs to be more understood, if you like. Gone one too far there. However, where given that there's really good monitoring externally, what about the internal environment? What is the government position on the internal environment? The one bit of good news is that they have got a committee called the Air Quality Expert Group, rather like SAGE, who looked at the pandemic. And the government are good at setting up these groups, a number of experts from across industry and science, but their focus mainly is on outdoor air quality, but they have written this really good report on indoor air quality, and set up a cross-government working level group as well on indoor air quality. All right, but this report, which is an excellent review, I think, of what the state is of legislation and pollutants and society's view of internal air quality inside buildings. They really aren't happy that there's anything positive that can drive a coherent strategy at the moment. So although internal air quality is a subset of air quality that sits within DEFRA, there's actually no clear ownership within government. There's a load of regulations, but they don't necessarily come together coherently at the moment. There's actually a lack of data on internal air quality, and whilst they point out that individual actions are quite simple, i.e. open a window, open a door, or turn the ventilation on, and that, or reduce emissions, there's actually pretty poor public knowledge of indoor pollution, even understanding there is indoor pollution, and a lack of enforceable standards for public spaces at the moment. So if you like, a bit of a hodgepodge and no clear direction in the same way that there is for external sources. So how to improve air quality in internal environments? this diagram I borrowed from the Royal Academy of Engineering. They've got a very, very good animation on this. But basically, what would we do? Start off natural ventilation, open windows and doors, mechanical ventilation. We've all been into buildings and looked at the fancy vents above, or the fancy ducting above. And at the end will generally be a machine that's going to be driving air in to ventilate, but equally will probably take air out and use the heat in that air to reheat the air that's coming in. So it's effective, unobtrusive, efficient, and it's viable year round, whereas opening windows and doors in winter is not viable and also can introduce external pollutants, and the mechanical ventilation can filter it out. But of course, expensive and a very difficult retrofit. The other thing we can do is monitor. So if we just read, this is a CO2 monitor, if we can just read what's going on inside, then of course we can make decisions about what to do there. This device here is an air purifier, and we'll come on and talk about them in a bit, but basically a filtering device in a room, okay? Fairly good idea if you can't do the big job, if you can't invest in the big thing, the air purifier can do a job in a room as a sort of at least a stopgap solution, okay? But as we said before, limited acceptance, indifference by the public, noisy, machine might be noisy. Where do you put it in a room? Who knows? Who's going to look after it, replace the filters, etc. So there are issues in terms of maintaining a strategy and maintaining equipment. So a design is needed, really, a design for a particular location. And it could be both machine or it could be process as well. How's it going to? How are we going to improve, and how are we going to make it stick? So there is a role there, and I'm doing a bad job of this beginning of this role now of educating and then listening to people, find out what their concerns are. So what's the problem? What are the solution? And what are the issues that need to be dealt with? So one of the things we did was CO2 monitoring, and these are little tiny devices. Talk about those in a minute. But why measure CO2? Well, it's a pollutant in its own right. High CO2, reduced concentration levels. But also, as we exhale CO2, we'll also be exhaling other biologically produced agents, and therefore it could be a proxy to help assess potential infection risk. It's easy to measure, and it's easy to offer some guidance against the measurement levels. And CO2 is persistent, it doesn't break down, therefore it's a good marker by which to also estimate the ventilation properties of a room. Its disadvantages are that if you've got a cooker, a gas cooker, that also produces CO2. Or if you burn candles in a ventilator, they produce CO2. And unfortunately, you can't filter it out with the air purifiers that we talked about earlier. So if you do have an air purifier, you don't know how effective that air purifier is by having a CO2 monitor. And of course, biologically produced agents will degrade and behave differently to CO2. So its application as a proxy is somewhat difficult to estimate, really. So a CO2 monitor, £200, battery lasts a year. And if we look here, this particular one has got a green, a yellow, and a red marker, and it's programmed so that when it gets to above 800 ppm, the black bar will move. Apologies. Will move across to the middle bar, and above 1500 ppm will move across to the red bar. So although it's a little difficult to see, actually you can take action. on those marks. So, for example, 800 ppm, good air quality, do nothing. Worsening air quality, you can ask people to start opening windows, and this little part of the slide is taken off an action plan for a particular venue. And above 1500 ppm, yes, make sure you have opened the windows, but also you could recommend that people take a break from the activity or reduce numbers in a room. So there's certain things you can do using that very simple monitor. Coming on to air purification, we mentioned that we could turn on an air purifier even if CO2 levels are high. But I think it will confuse people. And people have heard of HEPA filters. I think my vacuum cleaner's got a HEPA filter in it. And for taking out biological agents, you're looking at trying to filter out particles down at 0.2 microns, some really small. What's that? 0.2 millionths of a meter. It's a small number, okay? But filters are actually quite effective at doing this. And here's what a filter looks like: a random collection of fibers that can trap by interception, or the very small particles, just the gas molecules in the filter will grab them as well. Or they may have an electric charge depending on the filter type, and that will drag particles onto them. You'll notice here's you may have seen some filters, and often they're pleated, and that's just to maximize the filter area and that. But many devices with filters claiming to be filters, heaven knows what they're made of. And this particular filter that we've studied a little bit is one made by a well-known filtration firm, and this is actually not written on the machine. This is the certificate on the filter itself. It's an H14 filter with a definite airflow, and another sticker on it was a certificate, a test certificate on the filter itself. So to really know that they're working, that it is what it's supposed to be, then a certified machine is a good idea. Okay, looking at devices, all they are really is they pull air through the filter and then distribute the clean air back around the room. So the Camfill filter, that Camfill device we used, that Heeley Truss, looks a bit like this. This is a one you can buy. I've just bought one to dry my washing, actually. It's a dehumidifier, but with a H13 filter in it, apparently. But quite famous in the States with these things. They're called a Corsi Rosenthal box. They use a lot of air conditioning in the States, so they tend to have these lower grade filters on them. And people made these boxes by actually buying a simple box-shaped fan and duct taping filters that they could buy relatively inexpensively over there, and using them with claims of really good efficacy from these machines. And just the Wikipedia article will tell you something about them. However, to put a device into a public space, there is in fact a government specification, and as we'll see, looking at the various filters, it's only the Camfill expensive £2,000 machine that will meet the UK specification.
Can you just speed up a little bit? I just want to have a bit of time for questions, and we do have to finish at past.
Right. Anyway, issues with filters, essentially noise and people using them. Okay, we found this one noisy above a certain setting. I don't know about the other thing, and therefore will people use them? So what did we do in Heeley Trust? Well, Heeley Trust has several venues. We went to 2 public venues: Heeley Institute, Newfield Green Library, and looked at CO2 monitoring in both of those. This one with the university and Heeley Institute I did myself. This is what Heeley Institute is like, 350 meters cubed space used for a variety of things and no obvious ventilation in the place. So we put in 2 CO2 monitors and we enabled us to do remote data logging. And this is kind of what we got for a week. So here's CO2 up the side. Here's each of these little lumps is an activity going on in the room. Okay, and here's a massive spike, some activity, 3,000 ppm, but broadly creeping over the 1,000 ppm. But at the end of each activity, when everyone leaves the room, there's this characteristic down curve. You can just about see 2 colors there. That's a monitor near the door and one up above the windows, and really no discernible difference between the two. And over a period of a month, I found actually 20 groups, 50 events, and the peak level and the peak rate of increase of CO2, very different event to event. Okay, average length of meeting about an hour. The maximum, yeah, I'll leave the rest of this one. I'll move on. And what I did was look through the diary for the month and characterize by type what the booking diary told me. So I ended up with like dance classes down to just gentle exercise. Okay, week to week, the results were pretty much the same. So the dance class showed a similar trace week to week. But you can see that because of where it starts at a relatively low level of CO2, and the peak level 2,500 on average, and an average rate of increase of 1,000 ppm an hour, whereas the gentle exercise actually started at a high level of CO2 because it came in just after another event, didn't increase a lot over the time that it happened on. So most events were over the target of 800 ppm, 18% were over 1,500 ppm, in other words, what is considered to be poor air quality, and 12% well over 2,000 ppm. So sort of what could be done. So what I did was actually develop a little model, because I was really interested in this down phase to find out if we could estimate what the ventilation rate of the room was. And actually the method I use is pretty similar method is in the appendix of the internal air quality report talked about earlier. And I was able to invent the number of participants and actually match the curve with a model, match a real curve with a model, just by changing occupants, allowing a net rate of what people breathe out, and that would enable some what-if scenarios. So, and this shows that my inputs into the little spreadsheet. So basically, I could work out by putting in different numbers in here, basically, that the airflow would come out at the natural airflow somewhere around 180 meter cubed an hour is the natural ventilation rate in the room. Okay. And if I reduce the number, reduce that just on the model, then for the same meeting, I would have got a different, I'm predicting a different result. And if I increase the ventilation, then funnily enough, the peak would have been reduced. So it showed really that more ventilation would have a benefit. Now, to show how that kind of happened in practice, here was an event with a very, very high peak, okay? But this down curve was not at the 180 ppm, it was much higher. My estimate around about 700 ppm. And I reckon it's because doors were open there. Now, had the door been open right the way through this particular event, then they'd have at least halved the prediction of at least halving the amount they did. And using the same method, I could although I said that filters cannot remove CO2, you could sort of estimate what the effect of a filter would be, assuming that we emitted particles at the same rate that CO2 was produced. On a particular meeting, with one of the filter units in on setting 4, my estimate there was that we could reduce the risk factor, if you like. Wouldn't reduce CO2, but we could reduce the risk factor with a filter. And comparing air filters, just briefly using the same method, and again a health warning, because this can't happen in reality, but here I've just put in 10 people in a room, and with standard ventilation got a result like this. If I put in the filter we use, the CamFil, then we end up dropping by a third, and if I use it on a maximum setting, and also estimating the Corsi Rodenthal device, we could have considerably reduced the thing. But the interesting thing for me was that the crude homemade device is coming out as good as a medical quality device, which is pretty much what Wikipedia said. So I'm quite impressed at that.
Just very quick on the conclusion, Steve, because I do want to ask if there's any questions.
So in conclusion, there something needs to happen in Heeley Institute. I am going to move on a little bit more to do a couple more slides. So Sheffield Council had a little scheme on, and we worked with Sheffield Council and the University of Sheffield on another of their venues, Newfield Green Library, and they offered a 2-week placement with CO2 monitoring in place. So this was not me, this was them. We filled in a diary for them each week. They monitored levels remotely, and they were looking for behavioral changes on that. And here's the similar traces that we've seen before, but for Newfield Green Library. But the peaks lower than we were seeing at Heeley Institute. And what they were looking to do was introduce advice. And this was the university's output. So their summer and winter advice, what you could do in venues. And we adapted that and made some advice specific for Newfield Green. And what's happened is talking to Heeley Institute, Heeley Trust, the project's had a little more impact than what we might think. So the facilities manager's looking after it. CO2 monitoring system is going to go in at another site within their buildings. Most of the users at Heeley Institute have engaged with procedures that were introduced there, like using the filters, etc. Although some groups don't want to engage. Air quality at Newfield Green was actually better, and we put a monitor in there, and people have been using it, and they found their HVAC systems quite good. And they've been the monitoring and filtration units are in place at Heeley Trust offices, though they're not in use all the time. So sorry for a bit of a ramble there, but I have now come to the end, so I'm quite willing to take questions.
Wow, really impressive, Steve. I think it's a very important bit of work, and I'm sure it needs writing up. Could you just take down your slides, then I can see people, and we maybe have time for 1 or 2 questions. Just, have we got any? I just wanted to ask Steve, why? is there not a comprehensive program of research being done to prevent so much problems with the next pandemic? Because it just feels to me amazing that engineering departments up and down the country aren't working on this.
I mean,
Well,
what about the present pandemic?
Even, yeah.
Can I answer that then? I think the air quality report was published in 2022, and that identified those failings that were mentioned there. So in other words, there is an expert group there. So if there's pressure to be made, it's to the Department of Environment, the Secretary of State, and it's also making friends with that expert group, and that's the route in really to get things to happen. And all the references, all the issues really are contained in that report. So that's the ammunition by which to start emphasizing what's going on. But whilst we're focusing on COVID very much, that's the root of this project, the report tended not to. It had a load of other issues in there, the PM 2.5s, the VOCs from people just spraying themselves with deodorant and stuff like that. So there's a whole load of other pollutants to be considered, building materials, how to cover heating, reducing ventilation in order to keep people warm, but ensuring sufficient ventilation. So a whole load of issues that still need covering. And one of their strong recommendations was there should be more research projects and that. So more monitoring in more places.
Okay, we're time expired, I'm afraid. I just want to say thank you ever so much, students, Dania, Jack, and Mathilde, and to you, Steve.